Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Step 1. Identify the substrate and reaction. E3-methyl-2-pentene, CH3, CH is equal to C, CH3, CH to CH3, where the double bond is between C2 and C3 with a methyl group on C3 and an ethyl group continuing the chain. The E geometry means the two larger groups, CH3 on C2 and ethyl-bearing C3 chain, are on opposite faces. Step 2. Hydroboration oxidation mechanism. BH3 adds in a concerted SYN, CIS, fashion across the double bond. The boron and ultimately O goes to the less substituted carbon, anti-Markovnikov, and the H goes to the more substituted carbon. Both B and H add from the same face, SYN addition. Oxidation with H2O2O replaces B with O with retention of configuration. Step 3. Assign regiochemistry. Boron adds to C2, less substituted, bears only one methyl, hydrogen adds to C3. So O ends up at C2 and an extra H at C3. Step 4. Assign stereochemistry using the E-alkene geometry. In E3-methyl-2-pentene, viewing C2 is equal to C3, on C2 the groups are H and CH3, on C3 the groups are CH3 and CH to CH3, ethyl. E means CH3 on C2 and CH3 on C3 are on opposite sides, the higher priority groups are trans. SYN addition of BH3 from one phase gives a specific relative stereochemistry. The SYN addition from the bottom phase, less hindered, same phase for B and H, of the E-alkene places O and H at C2 and C3 in an anti-relationship between the O and the ethyl group producing the trio anti-product. Step 5. Analyze Newman projections. In option A, the Newman projection along C2, C3 shows front carbon C2 has O up top, at left H, right back carbon C3 has H, left me, right me, bottom. This corresponds to SYN addition onto the E-alkene giving the product where O and H are SYN added, with the correct relative stereochemistry, anti-relationship between O and the methyl on C3 consistent with SYN hydroboration on the E-alkene. Options B, C, and D represent either wrong regiochemistry, wrong stereochemistry, anti-addition products, or the enantiomer diastereomer arising from SYN addition on the opposite phase giving a minor or incorrect product relative to the major SYN addition outcome on E-alkene. Option A correctly represents the major product of SYN hydroboration oxidation of E3-methyl-2-pentene with OH C2 and the correct relative configuration. Therefore, the correct answer is A. Therefore, the correct answer is option A.